This is a video explaining how you can connect up a timer circuit in which an IC will enable an LED to pulse at a regular interval once a push button is pressed. This is an entry-level project to introduce you to digital circuits. You will need a collection of components including a breadboard, a 27 kilo ohm resistor, a 1 kilo ohm resistor, a 100 kilo ohm resistor, one 555 integrated circuit, or IC for short, an LED, a push button, a 10 microfarad capacitor, about 7 connecting leads, and a power supply. You should remember that a 100 kilo ohm resistor can potentially have two different color combinations. It could be brown, black, yellow, and gold, or it could be brown, black, orange, and brown. So do not allow this to confuse you. A resistor with either color combination is still a 100K resistor. For a power supply, you can use either a standard USB power supply buck and boost converter, or simply use a battery pack with two AA batteries. You can also use a 9-volt battery. You can find more details of the components at link 1 below the video. Make sure you connect all the components exactly as in the schematic diagram. You should also remember that the IC must be facing the correct direction. If you look closely at it, you will see that one side has a semicircle crescent shape. This must be facing left. Remember that both the capacitor and LED also have polarity, so be careful to find the longer positive leg and to make sure it is in the right section according to the diagram. If you are using the standard USB power supply buck and boost converter, simply connect the positive and negative leads in the same place as you would the leads from a battery pack. When working with digital circuits, it helps if you can visualize how the current passes through the components and the breadboard, as you can see here. You can find these schematic diagrams at link 2 below the video. Now I will explain a little bit about breadboards. If you're already familiar with breadboards, you may wish to skip this part. Remember that these sides flow horizontally, while these sections flow vertically. Also remember that there is no connection in the center of the breadboard unless your components are placed on each side or you use connecting leads. Remember, a breadboard and your power supply have polarity, meaning positive and negative sections. A word of advice: if you are using the USB power supply buck and boost converter, you should probably set the voltage quite low for this project, around 6 volts. Be extremely careful to connect the circuit correctly before connecting the power. If this is done incorrectly, you could damage your buck and boost converter. Also make sure the leads are secured using a screwdriver so they do not slip out. After you connect up all your components, if everything has been done correctly, the LED should flash at regular intervals, controlled by the IC. If you do connect the wires and it does not work as intended, carefully check all the connections and compare them closely to the diagram. You may also want to switch components, especially if they are old. The power source can often be the culprit. You may also wish to replace the IC. If you have a second one, you should definitely swap it, since sometimes ICs can become damaged if they are misused.